Hi, I've been making a few things over the last couple of years, and I wanted to share a bit of the journey I've been on around which hardware is really interesting to do that with. So the first place that a lot of people start off with is a Raspberry Pi, and that's something like this. It's pretty popular because it has lots of different ports that you know and recognize. There's USB ports, there's gigabit Ethernet, there's HDMI, there's USB, there's sound, and it's also got a GPIO header here. All these different pins here where you can go and connect different sensors and controllers and things like that. So that's pretty cool, but it's ridiculously overpowered. Like, these things can run dual HDMI screens these days. It needs a micro SD card plugged in the back of it to run an operating system. You got like 16 gig of storage right there. So as far as something goes for connecting to a few sensors, it's kind of cool, but it's also ridiculously overpowered. It also runs to about 50 bucks pretty quickly. By the time you add in, it needs a 3 amp power supply, it needs the SD card, and then the cost of the board. So it's not the cheapest of things to be really going and proliferating sensors around the place. Next place that gets interesting is going into something like this. So this is a Adafruit Feather, or specifically a HUZZAH32, and you can see a whole bunch of different pins marked across the bottom there. This is much, much smaller on the compute front. We go from like a gigahertz processor with 2 gig of RAM to this thing's like an 80 megahertz processor with 4 mega RAM. So it's much more right-sized to what we need from actually running a few basic sensors. What's on here is a stack of GPIO outputs, so digital and analog ones as well, for detecting kind of variable sensors. We've got a Wi-Fi and Bluetooth module, which is that big silver bit there. We've got a USB port in the end to go and program it, and also to give it power in a really easy way. And it's got one other port on the side, which is this one. It's tiny there, it's just 2 little pins, and that's for plugging in a LiPo battery, little 3.7 volt battery. This thing here can both run off the battery and it can also charge the battery. So it's plugged into USB, and there's the battery plugged in. You turn the USB off, it'll run off battery. When the USB is plugged in, it'll charge the battery. So that's kind of cool. These headers on the side here are both sockets at the top, so I can go and take like a DuPont jumper cable, and I can plug it straight into one of those sockets to kind of plug and play with stuff as I'm building things out. And there are also pins on the bottom. And where the Feather idea comes from is that you can stack some of these things. So I can take this as a compute module, and I can take another one like this, which has a little screen and just 3 little buttons on it. And I can just go and stack these things together by lining the headers up, squeeze them together, and now I have a screen that's attached to my compute unit. Because a bunch of the pins line up to drive kind of data buses across them. So that's pretty cool. If I want to keep adding functionality, there's also this kind of 3-way header block that I can get, or all sorts of different combinations. So this now has a 433 megahertz module to interface with my gate, and then I can add the screen on, and that all plugs together and all of that. So that's kind of cool. But that also starts to add up in terms of cost. We're talking sort of 20 bucks for this thing, and then 10 bucks for the screen, and 10 bucks for this bit, and all of a sudden you're back to basically a $50 setup again. So even just for this, it's how do we continue to slim this down? If all I want to do is read 1 or 2 sensors and maybe switch something on, I don't need things like a battery charge circuit and the stuff that drives a USB port. That really starts to drive the cost up. What gets interesting when you're looking into these chipsets is, well, people talk about the chipsets. So this one runs an ESP32, is that little silver bit. And sometimes people will talk about like an 18 mega or things like that. But if you start searching for that chipset, really the board that sits around it is just the different experiences that you can buy it in. If we go all the way down to an extreme end, that ESP chipset, the smallest form factor we can buy it in is this. Like, that is tiny. It's got basically half the board is a radio. It has 8 pins on the back of it, and it's like 1.5 centimeters wide. That tiny little square chip there, that there is the processor, it's the Wi-Fi module, it's like digital GPIO in and out, it's got an analog to digital converter on it, everything you need. And it's got 8 pins that exposes a few of those basic things. This thing is about $1.30 off AliExpress. It's ridiculously cheap, and if all you need to do is maybe read one thing and control a relay, that's pretty amazing. You can custom flash it, it'll connect to Wi-Fi, and it's kind of no bells and whistles, it does just what it needs to do. But what you sacrifice with going to something like this at $1 versus this at 20 bucks is some of those other nice things that make it easier to work with, like the USB port to program it. Like, how do you program this thing? What do you plug it into? And that's where we have to buy other modules. So in this setup here, and this particular form factor is called an ESP01S, and the chipset is an ESP8266. I can take this form factor and one of these little programmer boards, I can plug that together, I can USB that into my computer, flash some program onto it, and then go and unplug the chip, and we're off to the races. Cool. Still pretty cheap, $1.30 for this and like $2 for this, and you only need one of these. But then it comes time to, well, how do I actually integrate this into a project? Because this thing needs 3.3 volts, whereas your normal USB charger, kind of the easiest place to get power from, is 5 volts. So now you need to go and get a little voltage regulator as well. And you've got to take that and you've got to somehow wire these things together, and then you've got to apply power to it, and it starts to get a little bit hard and annoying. So that $1.30 is pretty amazing, but it's a little bit undersized for a lot of cases. While we're in that ecosystem though, this ESP01S, they also have relay modules that they make for it. So this one here, you can see the same yellow header, and I can take this chipset, so that's the compute and the radio, and I can plug it onto here, and that chipset now goes with this baseboard. This baseboard has the basics of, there's a little reset button on the end, it has a voltage regulator on it, so it'll take between 5 to 12 volts on these two little bits here. That's really easy because you can just unscrew, push some wires in, and off you go. It's got a relay for switching higher voltage loads, and specifically this will do all the way up to 250 volts at 10 amps, so you can actually switch 240 volt appliances with it at the right kind of current, if you're certified to do so, of course. And that's kind of everything you need to make that work. How do we power it? Get a USB cable, chop the end off it, get the power, go and put that into just those two little pins on the side, screw that in, and you've now got something that, for a grand total of $5 here and a USB cable that you've chopped off, it's Wi-Fi connected, custom logic, it can switch a relay, and it can sense an input. So that's pretty cool. The other thing that's in this ESP01S ecosystem is there's another variant of that, which is this one. So this is a temperature and humidity module, is that blue box, and the same concept, it's got a little reset button, and it's got a voltage regulator, and I can just go and plug the chip in the top, simple enough, and there's just two pins there for me to apply those 5 to 12 volts to, and we're up and running. Same thing, $5, temperature sensor, custom software, connects to Wi-Fi, that's pretty cool. All of these things though are looking very electronicsy, right? There's exposed boards, there's pins, there's like stuff flying everywhere. Do I really want to be going and mounting that in my projects? And this is where, when you start to research this ESP ecosystem, there's so many other form factors are available. And I think this one's the coolest I've found. This here is an M5Stack Atom Lite. Now, this is a tiny little thing. You can see the size of it there. It's like 2 centimeters squared. And in this, it's got the same kind of chipset as, what we're running on one of these, that ESP8266, but it's got a really great little form factor. So first of all, on the bottom, we've got a USB-C port is the one at the top. If I give you a sense of scale by putting a plug into it, well, smallest USB-C cable, like the port is half the size of the thing, right? So with that, we can power it. We don't have to go chopping cables off. We can just buy a USB-C cable, plug it in. This thing is now powered. On the top, it exposes a series of those GPIOs, or those kind of inputs and outputs. Now these here, rather than being exposed as a whole bunch of pins that stand up like all of the other form factors, they're little sockets. And what that means I can do is, again, I can just grab a little DuPont wire and I can just plug straight into one of those and we're off and running. So it's kind of like a breadboard, except it's a breadboard that's integrated with the chip. Because what I find that's cool about this versus something like this is these types of things, you usually see them start on a breadboard and then they never progress to the actual project. Whereas here, most sensors only require a couple of wires to plug in and off you go. So that's pretty cool. What's also on the top here is all of those pins are labeled. So it's a bit hard to see on that bit there because I'm especially so shaky, but it's all labeled with G so-and-so, the 3 volts, the 5 volts are all exposed. There's actually a button on the top here that you can click and that gives an input sensor. There's a reset on the side. There's an LED in the top. There's a little note panel on the end so you can write down which thing it is. Lots of different cool things in this form factor, and it's nice and packaged up in a bit of plastic as opposed to something that has lots of sticky outy bits kind of hanging around and a little bit not the best way to package up something. So that's kind of cool. When we think about then just going and grabbing random sensors, most sensors typically require 5 volts, ground, and then some kind of data pin that comes out of them. So in a lot of cases, you could go and take the sensor, whatever the wires are off the end of it, actually put those wires straight into those holes, apply some USB power just by plugging that in, and then literally just put some electrical tape around it, and you've got something that is now flashable, on the Wi-Fi, custom sensor plugged in, no soldering required, not a lot of exposed electronics. Now these things here, these Atom 5 stacks, the light version, that's $5. So that gives you all of the advantage of that tiny little ESP processor, which was $1, but it includes all of the power management, a bunch of really nice pins, LED breakouts, and all of that for $5. It's a much nicer form factor than this, which is 4 times the price, and it's way nicer than this, which is $50 and completely overpowered for anything you need and sticky outy bits everywhere, and you got to buy a case. The last bit to kind of polish this off, give you an example of some of the way this can go together. What it means is we can go and buy something like this, just a random, this one's a capacitive soil moisture sensor, exactly what you need. Comes with a cable attached to it, a couple of DuPont wires, plug it into here, and apply power, and you're off and running. And that's obviously not going to work outside, so probably not the best example with the soil moisture sensor, but it'd be pretty easy to put that in a little box, apply some power to it, and you're off and running. The other thing that these things have, so if you don't just want kind of random wires plugging in and hoping they don't fall out the bottom, is next to that USB-C port is also a Grove port. So that's this like white bit here. And you can go and buy some Grove tails. They come in like bundles of 10 of them for like $2. You can buy some of these. They've just got a plug in 4 wires, exposed end. That plugs into there. Already marked on the top is those 4 wires, exposed ground, 5 volts, and 2 GPIOs. And then just solder that onto your sensor. So you've got potentially 3, maybe 4 wires you need to solder. Put a nice little bit of heat shrink on there. You've then got a really good plug quality connection into here. You add your USB-C and you're off and running. So you've got custom sensor with a flashable little chipset that talks Wi-Fi that you can put a little node on the end of that takes USB-C power, and that whole thing is $5 plus just a USB-C charge you find lying around. And then if you really want to step it up to the fancy version, there's also the full M5 stack, which this one is a little bit bigger. You can see it's bigger than the light version. And what comes on top of here is actually this, and that's a 5x5 matrix screen. So you can put little display outputs and stuff like that on it, and make all that glow in funky colors. But otherwise pretty similar form factor. And then the processors in these are actually really, really powerful. They're dual core, they do way more than you need for most sensor applications. So that's a crash course, trying to take you from the idea of where most developers start at a Raspberry Pi, down to this thing for $5 that's USB-C, that's plug and play, and it will actually get you off the breadboard and get you into production, rather than prototyping something out and then having to go, oh, now how do I mount this thing and solder it all up and all of that. So M5 Stack,